So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP-18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. Now, don't be nervous, but there is a hole in our universe. Is it leaking? It's larger than anything we've seen before. The human mind can't even imagine something this huge. Well, mine sure can't. Is it a growing black hole? Is our solar system going to end up sucked into this giant nothingness? Am I blowing this all out of proportion? Well, let's figure it out. The universe isn't packed evenly with stuff. Huge empty areas, called voids, make up about 80% of it. Our own Milky Way even sits inside of one, known as the local hole. But one void is on a whole different level. It's called the Boötes void, and people often nickname it the Great Nothing. It's a massive, almost empty bubble of space located far away in the Boötes constellation. Its sheer size makes this bizarre formation unbelievable. The Boötes void stretches a whopping 330 million light-years across. For comparison, our little solar system has a width a bit more than 3 light-years. Yet the Boötes void contains very few galaxies. Compared to the rest of the universe, it's basically empty. That makes it one of the largest known voids, and one of the biggest empty spaces we've ever found. If our galaxy were inside the Boötes void, we wouldn't have seen any other galaxies for most of history. Until the 1960s, our telescopes just weren't powerful enough. Other galaxies would have been way too far away and too faint to spot. It wasn't until the 1960s, when telescopes got much better, that we could finally see very faint, faraway galaxies. If we had been living inside that void, that's when we would have first realized other galaxies even existed at all. But let's figure out a very important question. How do such giant empty spaces even form? After the Big Bang, all the matter in the universe started spreading out, but it didn't spread out perfectly evenly. Tiny random differences, called quantum fluctuations, meant some areas had a little more matter than others. The denser areas had stronger gravity, so they pulled in even more matter. Over time, this left other regions almost empty. That's how galaxies clumped together, and how huge voids were created in between. So over time, galaxies attracted each other too, linking up into long thread-like structures called filaments. Together, those filaments formed a massive foam-like web across the universe. The galaxies gathered along the threads, while the empty spaces in between became voids, kind of like bubbles in foam. Smaller voids slowly merged into bigger ones, which is how enormous regions like the Boötes void formed. Today, filaments and voids make up the largest structures in the universe. The filaments are hotter and more energetic, while the voids are colder and much emptier. Now, the Boötes void is enormous. It makes up about 0.35% of the diameter of the entire observable universe. But inside this massive space, there are only about 60 galaxies, mostly stretched out in a tube-like shape through the center. Normally, a region this size would contain around 2,000 galaxies. The void is also surrounded by massive galaxy clusters, like Ursa Major, Shapley, Hercules, Corona Borealis, and Boötes. This makes the emptiness in the middle even more shocking. Now, scientists first noticed those huge empty spaces and big galaxy groups in the 1970s, when new technology finally let them see the universe in 3D. As for the Boötes void, it was discovered in 1981 by American astronomer Robert Kirshner from the University of Michigan, which also has a pretty good football team. At the time, he and his team were mapping the universe in 3D by measuring how fast galaxies were moving away from us. This method is called a redshift survey. So while doing this, they noticed something weird, a huge region of space where almost nothing showed up. It was basically a giant blank spot on the map. Scientists ruled out a few dramatic ideas right away. The Boötes void isn't a black hole because it does contain a small number of galaxies, just far fewer than expected. It's also not a dark nebula, which is a dense cloud of gas and dust that blocks out light. The Boötes void isn't hiding galaxies. There simply aren't that many to begin with. The Boötes void helps scientists learn how the universe changes and grows. Because it's so empty, it's a great place to study dark energy. Our universe consists of normal matter, and dark energy. Normal matter is everything you can see with your own eyes or with the help of instruments. It makes up around 5% of the universe. About 27% of the universe is dark matter, and dark energy takes up around 68%. It's a force responsible for the expansion of the universe. We really don't know what dark energy is, so scientists are excited about any chance to study it and learn more about how it works. Voids are also useful for studying neutrinos, tiny particles that can travel throughout space without getting stuck. They're often called ghost particles because they're almost impossible to catch. They fly through space and through us without leaving a mark. Right now, trillions of them are passing through your body and you don't feel a thing. Neutrinos are made in places with lots of energy, like the Sun, exploding stars, and nuclear power plants. They are everywhere, second only to light particles in the universe. What makes neutrinos really strange is that they can change as they travel. They come in 3 types, and they can switch between them while moving. Scientists also don't know how much neutrinos weigh, or which type is the heaviest. Learning more about them could help explain how the universe works. Well, anyway, with time, space missions will look closely at these empty regions. By comparing what they see with computer predictions, scientists hope to learn more about neutrinos and better understand how the universe works. One of such space missions is Euclid. Its data will be used to study and analyze the Boötes void and other similar cosmic voids. Euclid's job is to study the dark universe. It does this by making a huge 3D map of space, looking at billions of galaxies as far as 10 billion light-years away and covering a big part of the sky. Now, scientists know that dark energy makes the universe expand faster, and dark matter helps galaxies form and stick together. But they still don't know what either of them really is. By watching how the universe has changed over the last 10 billion years, Euclid helps scientists understand how space grew, how galaxies formed, and what dark energy, dark matter, and gravity might actually be like. Euclid is about 15 feet tall and 12 feet wide. It has 2 main parts. One part runs the spacecraft, like power, computers, and steering, and the other holds the telescope and 2 cameras. One takes pictures in visible light, that's what our eyes can see. The other sees in infrared light, which helps scientists spot very distant galaxies. Now, Euclid launched on a SpaceX Falcon 9 rocket from Florida in July 2023 and officially started doing science in February 2024. It now orbits far from Earth, nearly 1 million miles away. It stays in a special spot in space where it moves with Earth around the Sun. This keeps its view stable and makes it easier to study the universe. Euclid is supposed to work for about 6 years, but it might keep going longer if it doesn't run out of fuel. In October 2024, Euclid released the first part of its huge map of the universe. Over time, it'll scan more than 1/3 of the sky outside our Milky Way galaxy, capturing billions of galaxies, some so far away that their light took up to 10 billion years just to reach us. The images taken by the space probe are about 4 times sharper than those taken by telescopes on Earth. Euclid also studies light in detail to learn what galaxies are made of and how they move. It'll do this for hundreds of millions of stars and galaxies. And all of this will create a massive space data library, one of the biggest ever made by a space mission. Oh, by the way, Euclid was named after an ancient Greek mathematician who helped invent geometry, the study of shapes in space. Scientists picked this name because understanding the shape of the universe helps explain how matter and energy are spread through space. So now you know. Asteroids, unseen but perilous, are traveling in the same orbit as Venus, and our telescopes just can't detect them. The threat is real. If one of these objects heads toward Earth, we're all doomed. Well, maybe. In that not-so-distant, relatively of course, stretch of space where Venus orbits, there may be hundreds of asteroids we've never detected. They could be circling the Sun right at this moment, but they stay completely hidden from us. The problem is their position. Because they're closer to the Sun than Earth is, we can only look for them by pointing our telescopes almost straight toward the Sun. Any sunlight they reflect gets swallowed up by the Sun's brightness, so they basically disappear in the glare. These objects aren't part of the main asteroid belt between Mars and Jupiter. They're much closer, moving through the inner solar system. They travel in what's called a 1-to-1 resonance with Venus. It means they orbit the Sun in almost the exact same period as the planet. This makes them Venusian co-orbital asteroids, rocks that orbit the Sun in the same area as Venus instead of having their own separate path. Now, researchers use computer modeling and long-term simulations to figure out how these hidden asteroids behave and whether they could ever threaten Earth. The results aren't reassuring. The orbits of these asteroids aren't stable, their paths shift over time, and about every 12,000 years, their whole orbital setup can change. An asteroid that stays close to Venus for thousands of years can eventually drift away from it and come much closer to Earth's orbit. Now, Jupiter has its own group of co-orbital asteroids called Trojans, but those are much more stable, and the planet is so far from us that even unstable ones wouldn't be a problem. The Venus co-orbitals are different. They're close, and their orbits can change enough that some of them may eventually cross Earth's path. So even though these asteroids are invisible to us right now, the models suggest that some of them could one day get close enough to pose a real risk to our planet, even if that risk is thousands of years away. Now, even worse, scientists think that the small number of Venus co-orbital asteroids we've already discovered is only a tiny sample of what's actually out there. They suspect that most of this population is still completely unseen. Some of these hidden objects may be almost 1,000 feet wide. Such an asteroid is large enough to create a crater about 2 to 3 miles across if it ever hits Earth. Oh boy. An impact of that size would release energy equal to hundreds of megatons, causing massive destruction if it happened in a densely populated region. An asteroid would slam into the planet with enormous force, turning solid rock into vapor. Everything, and everyone close enough to see the crash, wouldn't live long. The ground around the impact crater would be covered with hot ash, grit, and rubble. Grass, trees, and shrubbery around the crash site would burst into flames. But that's not the worst thing. The impact would trigger a series of natural disasters, such as tsunamis and earthquakes, depending on the region. The sky would get almost completely black because of all that ash in the air. It would block the sunlight. Rainwater would get highly acidic. Fires would keep raging. They would produce enough toxins, harming the ozone layer. Earth's shield against the sun's radiation and heat would weaken. Even though humans would probably survive, the quality of life would plummet, and no one knows how long it'd last. So far, the Venus co-orbital asteroids we have found all share one thing. They follow stretched-out orbits. Their eccentricity is higher than 0.38. Eccentricity is just a measure of how round an orbit is. A value of 0 means a perfect circle. Earth's orbit is 0.017, which is almost a circle. The higher the number, the more oval the orbit becomes. And since these known asteroids follow long stretched paths, they can drift far from Venus and swing closer to Earth. When that happens, we can sometimes spot them during twilight, when the sun is below the horizon but still bright enough to light up small nearby objects. Scientists wanted to understand the asteroids we couldn't see yet, especially the ones with more circular orbits. They ran simulations to study how those lower eccentricity asteroids might move, whether any of them could threaten Earth in the near future, and whether the new Vera Rubin Observatory, with the biggest astronomy camera ever built, would be able to spot them. The results showed something worrying. Even some low eccentricity orbits could bring long-term risk to Earth. Even worse, the Rubin Observatory will only be able to see these objects during short windows at certain times of the year. That means many of them could still slip by unnoticed. Now, this creates a real problem for planetary defense. It's hard to prepare for the danger if you can't see it coming. One way to fix this blind spot would be to place a space observatory near Venus, or even in the same orbit as Venus, so it can watch that region directly. NASA's upcoming NEO Surveyor mission might also help by studying the inner solar system, where these objects hide. In the end, scientists think ground-based surveys like the Rubin Observatory will catch some of these asteroids, but not all. To map the full population of Venus co-orbitals, we'll need a dedicated space mission close to Venus. Right now, astronomers have identified only 20 Venus co-orbital asteroids. All but one have an eccentricity higher than 0.38. These stretched-out orbits carry them farther from the Sun, where telescopes on Earth have a fighting chance to spot them. But there should be many more asteroids with more circular paths that stay closer to the Sun's glare. So, what if we spotted a visitor from Venus when it was already approaching Earth? What would we do? Well, we could launch a bunch of nuclear explosives at the asteroid. If we could just blow it to pieces while it was still far away, the debris would scatter safely into space instead of causing problems near Earth. On the other hand, what if the explosion accidentally changed the asteroid's path and sent some fragments toward Earth? It's a real possibility. Or we could gently nudge it off its course toward Earth. But it would only work if we knew exactly the weight of the asteroid. Without knowing its mass, space agencies wouldn't be able to design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it, and figure out the best way to push it away. But what if we didn't have enough time for that? By the time we collected all the needed data and built the right hardware, it'd be too late to intercept the asteroid. By the way, NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a major difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera's on a 2-year journey to reach Dimorphos and its bigger partner asteroid, Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. In any case, planetary defense has to think about more ways to protect the planet from wayward asteroids. It also has to take seriously the things we still can't see.
In 2024, Earth was joined by a mini-moon that orbited around our planet for 2 months. It hung around, made a few laps, and then, like every polite guest, it left. It went back to resume its trip around the Sun. However, astronomers now say another rock has been tagging along with Earth not for weeks, but for 6 decades. It's rare and strange, now being classified as a quasi-moon. But what exactly does that mean? Is it like a backup satellite? Unlike our cool and mysterious moon that illuminates our nights and affects werewolves, a quasi-moon doesn't circle Earth. Instead, it orbits the Sun, but it does so almost in perfect sync with us, like a runner doing a marathon with you that keeps a similar pace. Space only seems calm. It's actually pretty chaotic. The Sun, the Moon, Earth, and even other planets are constantly tugging on each other and smaller objects like these rocks. Most asteroids can't hold this delicate balance for long. They either get nudged into a new orbit, pulled closer to Earth, or flung out into the vast reaches of space. That's why we're lucky to spot more than 1 or 2 at a time. Most just can't keep the balance. They belong to a bigger family called co-orbitals. In fact, astronomers group them into a few types based on how they move relative to Earth. But unlike the real moon, that's been our companion since the very beginning, these visitors don't stick around forever. Some hang with us for a few decades, others for centuries, before drifting away because the gravity of some other space object. Kinda like a dog running to your neighbor after smelling bacon. One other thing about quasi-moons is their size. Most are tiny, building-sized or even smaller. They're also so dim that they can hide in plain sight among stars. Still, they're important. By studying them, astronomers learn how small near-Earth objects move and how long they can stay caught in Earth's gravity. Quasi-moons are closer than other asteroids on the same path, and it would be easier to reach them. One day, they might be used as stepping stones in space exploration. Earth has had a few of these tag-alongs before. One of the most famous is 2016 HO3, nicknamed Earth's Constant Companion. It's only about 300 feet wide, but it's been keeping pace with us for nearly a century. Researchers say it might keep up for centuries more. But what about the most recently discovered one? The researchers named it 2025 PN7. Like we said, it's already been with us for 60 years and will likely stay for around 68 more. For a long time, it remained undiscovered because of its tiny size, only about 62 feet across, which is about the length of a bowling lane. This also answers the question of whether you could see it yourself if you knew where to look. Its backstory is a bit of a mystery. Astronomers haven't figured out its composition yet. Right now, all we know for sure is its trajectory. Some quasi-moons are just near-Earth asteroids that fell into a perfect orbit. Others seem like they could be chunks of the moon itself. For instance, there's another quasi-moon named Kamo'olaloa that reflects light in almost the same way as the lunar rocks we brought back during the Apollo missions. Because of that, some researchers think it might actually be leftover from a huge impact that happened long ago. There's also 2024 PT5, a temporary mini-moon from the end of last year. Tests showed that its surface looked like lunar basalt, suggesting it probably came from the moon. So how do these quasi-moons pull off their cosmic balancing act? That's because it's just an orbital illusion. Remember, PN7, like other quasi-moons, isn't actually circling our planet. To us, it looks like the rock is scribbling lazy loops around Earth's path, like doodles in space. Yet it never lags too much or gets too far. Astronomers call this a one-to-one resonance. In plain English, it makes a lap around the sun every time Earth does. Another fun question. If these fake moons are so close to Earth, why don't we just pull them in with our gravity? Especially since they're tiny and seem so near. That's because even though they belong to a group called near-Earth objects, quasi-moons are not that close. Our moon is hanging out about 239,000 miles away. These companions, though, are flying around the sun millions of miles out, way beyond Earth's gravitational pull. That pull exists within an area called the Hill sphere, which is where Earth's gravity is stronger than the sun's. Think of Earth's gravity as a bubble with a radius of about 1,000,000 miles. Anything inside can get caught, like the real moon. Step outside, and the sun takes over. This is exactly what happened to PT5, which was our legit satellite for 2 months in 2024. It dipped inside the Hill sphere, and Earth's gravity took over. Once it happened, this object became known as a mini-moon. But because it was small and moving fast, it eventually slipped back out of that bubble, and the sun's gravity pulled it away again. One other type of co-orbiter, aside from quasi-moons and mini-moons, is the so-called horseshoe orbiters. These space rocks don't stray far, but from Earth's point of view, they seem to swing ahead of us, slow down, then drift back behind, and repeat. It's like an undercover cop tailing you in traffic, but constantly switching lanes and doubling back so you don't notice the pattern. If you trace their motion from Earth, over time, it forms a giant horseshoe shape, hence the name. And these are just the main co-orbiters. There are actually more. Way ahead of us and way behind us in space, there are a few quirky rocks called Trojans. They're not just following right next to Earth like quasi-moons do. Instead, they found 2 special hiding spots. one 60 degrees in front of us and one 60 degrees behind. Imagine riding your bike and having a friend way ahead of you and another one way behind, both keeping the same speed. That's what Trojans do. Those spots are called Lagrange points, cozy hangout regions where the gravitational pulls from Earth and the Sun balance out perfectly. When they find themselves in one of those areas, they could be staying there for millions of years without drifting away. Jupiter, for example, has tons of these freeloaders. Earth has only a few. Then there are tadpole orbiters. Instead of sitting perfectly still in a Lagrange point, they wobble around it in lazy bean-shaped loops. And if that's not confusing and overwhelming enough, there are also jumping Trojans, the indecisive ones. These guys can't pick a side. They'll spend a few thousand years staying in the front hammock, then slowly drift to one behind us and back again. Rare, weird, and kind of awesome. So even though Earth only has one big moon in the sky, we've actually got a whole gang of intrusive space tagalongs. Some loop, some trail, some hide in the corners. Now let's recap the superpowers of our moon. It can affect tides, slow down Earth's rotation, and even help stabilize our planet's tilt. Without the moon, our days would be shorter, our nights darker, and the seasons way more chaotic. The moon also acts like a giant shield, sweeping up or deflecting some space rocks that might otherwise smack into Earth. And let's not forget its cultural influence. It's been inspiring myths, calendars, love songs, and millions of melancholic walks in the middle of the night. Fake moons can't compete. However, they are important in their own way. Each new quasi-moon we find helps us understand how these little rocks survive in all that cosmic chaos. By learning about our environment, we also learn something about ourselves. They sharpen our detection skills and help us improve our models. So while they'll never shine in the night sky, they still play a quiet role in helping us understand our quirky cosmic neighborhood.
A star is like a cosmic engine, crushing atoms together under insane pressure and blasting light and heat across billions of miles. Now, combine it with a black hole, a trap so powerful that even light can't escape it. The monstrosity you get as a result seems like stuff from science fiction, but might actually be a very real space object. When the James Webb Space Telescope started looking at the universe in 2022, it spotted something super bizarre. There were these tiny red dots scattered across the sky, and they were from times when the universe was very young. It was something no one had ever seen. So astronomers were totally baffled, but they still managed to cook up a few theories. So one idea was that these red dots were mini galaxies, but not your regular small galaxies. These would be only 2% the size of the Milky Way, packed with so many stars that it would make them a cosmic mosh pit. But that would be so dense it might just break the laws of physics. So this theory isn't very plausible. Could those dots be quasars, glowing, star-devouring black holes? No, they're too faint for that. And if a black hole that big existed in something so tiny, the galaxy would be like a backpack trying to carry an elephant. Not gonna happen. It's time to get acquainted with Avi Loeb, known for his pretty extravagant ideas about civilizations from other planets, and his teammate Fabio Pacucci. They think these little red dots are galaxies, but super tiny because they haven't even started spinning yet. Picture a baby galaxy still learning to walk. Hey, there you go. This idea comes from the main theory of how galaxies form. They grow inside halos of hypothetical dark matter, the invisible stuff that makes up 85% of all the universe's mass. You can't see it or touch it, but its gravity acts like cosmic glue, pulling galaxies together. And those tiny red galaxies could be cradled in dark matter, waiting to start spinning and growing into the big galaxies we see today. The astronomers think these baby galaxies could live in halos that spin super slowly, more slowly than 99% of halos in the universe. It's easier to picture if you imagine holding a rope and spinning around. Spin fast and the rope flies out. Spin slowly and the rope just droops to the ground. That's exactly what could have happened with these galaxies. The halos were too slow to stretch them out, so they kept the galaxies tiny. This could help explain why we only see such red dots in the universe's baby pictures. Over time, the halos would speed up, and the galaxies inside would grow and spread out, eventually looking like the galaxies we're used to. Loeb explained it like this: dark matter halos have a rotational velocity. Some spin fast, some spin slowly. If you assume that these little red dots are in the slowest 1% of halos, all the strange things we see about them suddenly make sense. But the thing is, this isn't the only explanation. Two other teams of astronomers have recently suggested that these dots could be something totally new, a type of cosmic object they call black hole stars. An international group of astronomers and physicists, including experts from Penn State, think these dots are actually giant balls of hot gas that are so dense they look like the atmospheres of normal stars. But instead of being powered by nuclear fusion like regular stars, these are fueled by supermassive black holes in their centers. The black holes gobble up matter, turning it into energy, and that energy gives off the light we see. After looking at enough red dots, scientists found one with so much atmosphere that it couldn't be explained as just a bunch of normal stars in a tiny galaxy. Instead, it's basically one enormous, very cold star. Now, cold stars don't emit as much light because their temperatures are low compared to your typical stars. Most stars in the universe are low-mass, colder stars, but they're usually hard to spot because the brighter, massive stars shamelessly steal the show. As for these black hole stars, they shine in the red and near-infrared wavelengths. It's light we can't see with our own eyes anymore. And even though the gas around supermassive black holes is usually millions of degrees hot, the red dot black hole stars could be surrounded by very cold gas, like a low-mass star's atmosphere. This could explain why they glow so faintly. So, in other words, what we thought were tiny galaxies full of stars might be single giant stars powered by black holes. Now, let's figure out how the James Webb Space Telescope helped astronomers make this discovery in the first place. It's one of the most powerful telescopes in space. It was designed to look all the way back to the birth of the universe, using infrared instruments to detect light from the oldest stars and galaxies. Basically, it's a time machine that allows scientists to see the universe as it was about 13.5 billion years ago, right near the beginning of everything. The moment the James Webb started scanning the skies, astronomers noticed tiny red dots popping up everywhere. And those objects were way too massive for what galaxy models predicted. At first, the team thought they were just mature galaxies, which get redder as their stars age. But the dots were way too bright. To explain them as galaxies, the stars would have to be packed together so tightly that it seemed physically impossible. You see, a galaxy like that would make the night sky blindingly bright. To figure out the mystery, the scientists needed spectra. That's data showing how much light the objects gave off at different wavelengths. Between January and December 2024, they spent nearly 60 hours of James Webb time collecting spectra from 4,500 distant galaxies. It's one of the biggest spectroscopic datasets ever taken with Webb, and it gave astronomers an unprecedented peek at the dawn of space. In July 2024, the team spotted an incredibly extreme object. It immediately grabbed their attention. They nicknamed it the Cliff because it became the perfect test case to figure out what those mysterious red dots really were. The object spectrum showed an enormous amount of mass, the most extreme case of its kind detected so early in the universe. The light from the Cliff had traveled nearly 12 billion years to reach Earth. But the weirdest thing was that spectral analysis showed that the light wasn't coming from a cluster of stars at all. It was coming from a supermassive black hole. This black hole was pulling in surrounding matter at an incredible rate. wrapping itself up in a ball of hydrogen gas. Black holes like this are usually found at the center of galaxies, sometimes millions or even billions of times more massive than our Sun. Their gravity is so strong that matter falling in gets converted to energy, producing enormous amounts of light. The discovery of the cliff and similar objects shows that these black hole stars might be the baby version of the supermassive black holes we see at the centers of galaxies today. Yep, astronomers might be witnessing the universe's most powerful monsters as babies, before they grew into the huge giants we know. The James Webb has already spotted signs of big black holes in the early universe. And these black hole stars might explain how the universe grew so fast. You can think of them as turbocharged space builders, sucking in matter, getting bigger, and powering up the early cosmos. The scientists plan to study them more to see how dense their gas is and how strong they really are. As for the little red dots, they're super far away, both in space and in time. And they're so tiny that studying them is tricky. But for now, the black hole star idea is the best explanation, fitting just about all the data. Researchers are working to figure out the rest, and even if some guesses turn out to be wrong, astronomers will just follow the clues, and the next idea is bound to pop up.
A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible. At least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to ArXiv, which is where science nerds drop their ideas before they hit the big journals, and it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar. At least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie. Magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now, let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby: gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pavlovsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet. But other experts think Poplavsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life, like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life, as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Hessian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggest it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. Now, I don't want to freak you out, but something bizarre has erupted in the depths of space. It was an explosion brighter than billions of suns. But the real mystery is that it doesn't match anything astronomers have ever seen. Usually, cosmic events like this follow familiar patterns, but not this one. It's a cosmic anomaly. This strange cosmic explosion has left astronomers totally baffled. It could be a super rare event where everything lines up just right. Or it could be something completely new, never seen before. This event was first detected by an X-ray space telescope called the Einstein probe on April 8, 2024. It first appeared to be a regular gamma-ray burst. Those typically give off incredibly bright X-rays. But could the answer really be so simple? Something didn't add up. Now, gamma-ray bursts are the most powerful explosions in the universe, and they can happen in unusual ways. Long-duration gamma-ray bursts are caused by the demise of massive stars that spin incredibly quickly. When these stars run out of fuel, their cores collapse under gravity, forming an extremely dense object like a black hole. At the same time, the outer layers of the star are blown away in a massive explosion called a supernova. Gamma-ray bursts are followed by jets. Those are twin beams of material shooting out from opposite sides of the collapsing object. They're super fast, moving at nearly the speed of light. These jets appear brighter if they're pointed directly at us. It's like how a flashlight beam is brightest when it's aimed straight at you rather than at an angle. Now back to our unusual cosmic explosion. Remember me telling you something wasn't adding up? Hey, it was just 45 seconds ago. Well, the problem was that when multiple telescopes observed this event in different wavelengths – ultraviolet, optical, near-infrared, radio, X-rays, gamma rays, you name it – it didn't match any known type of event. The most likely explanation, according to current research, is that this explosion is the result of a white dwarf star being torn apart by a medium-sized black hole. And still, it's not so simple. Now, black holes are areas in space where gravity is so strong that nothing, not even light, can escape. That's why they're called black holes. It's believed that stars with at least 3 times the mass of our Sun can collapse under their own gravity once they run out of their stellar fuel. When a star has so much mass packed into such a small space, its gravity becomes so powerful that it forces everything, including atoms, to squish together. This intense density leads to the formation of a black hole. So, when a white dwarf star is torn apart by a medium-sized black hole, it results in a high-speed jet of material that can be aimed directly at Earth. So, could this space disaster be the reason behind our mysterious event? Unfortunately, even though it ticks some boxes for several types of phenomena, including the one involving a white dwarf, it still doesn't fit all the criteria for any of them. The event's short duration and high luminosity are hard to explain using any scenarios we can produce. So, does it mean we have come across something completely new? The universe is full of energetic flashes caused by outbursts from stars and black holes, supernova explosions, stars being eaten by black holes, and other cosmic events. Astronomers usually figure out what these events are by analyzing their duration, frequency, source, and the specific combination of wavelengths they emit. Here, I just have to say a few words about the instrument that discovered the space anomaly. The Einstein probe is an X-ray space telescope project led by the Chinese Academy of Science in collaboration with the European Space Agency and the Max Planck Institute for Extraterrestrial Physics. That's a mouthful. This project is all about studying high-energy space events over time. Its main goal is to find inactive black holes and figure out how matter falls into them by spotting X-ray flares produced by these sudden space events. The Einstein probe also hopes to catch the electromagnetic signals from events that cause gravitational waves, like when neutron stars merge. It also keeps an eye on the whole sky to spot all kinds of space explosions and track already known changing X-ray sources. After the Einstein probe detected that ultra-bright space flash, the event was also observed by a few other ground-based and space telescopes, including the Nuclear Spectroscopic Telescope Array, SWIFT, Gemini, Keck, Dark Energy Camera, Very Large Array, Australia Telescope Compact Array, and Neutron Star Interior Composition Explorer. That's a bigger mouthful. Using all this data, astronomers pieced together the event's characteristics, but it didn't make the case any clearer. Quite the opposite. It just deepened the mystery. This event flared up in soft X-rays for the first 10 seconds, then plateaued at a steady glow for about 4 days before fading quickly within another day. This is much longer than typical gamma-ray bursts, which usually last from a few milliseconds to several hours. but it was still not long enough to fit into other known categories. The event's brightness in X-rays was also unusual. It was too bright for some types of phenomenon, but not bright enough for others. The most puzzling part is that the Very Large Array didn't detect any radio emission from the source when it was observed 11 days, 158 days, and 258 days after the initial flare. Now normally, when something this bright in X-rays lasts for this long, it's usually associated with a luminous radio counterpart. But in this case, no radio signals were detected, which is very strange and adds to the mystery. Astronomers didn't give up and considered several other possibilities, like fast blue optical transients. Those are a new class of explosions that release huge amounts of energy and blast matter into space at incredibly high speeds. These bursts are so powerful that one F-bot can be at least 10 times more powerful than a regular supernova. Fast blue optical transients do look like supernova explosions, but they are much faster. They flare up and fade away much more quickly than regular supernova. They're also much hotter, which makes the light seem bluer compared to other supernova. Since these explosions happen so quickly, it's tough to figure out what causes them. In January 2019, astronomers narrowed it down to two causes: a black hole consuming a white dwarf star, or a rare kind of supernova that leads to the formation of a neutron star or a black hole. Now, another explanation for our mysterious space explosion, and astronomers think it's the most likely one, is a tidal disruption event. It happens when a black hole swallows a star, causing a flash of light. When a star gets too close to a supermassive black hole, it doesn't get off easily. No, the black hole's powerful tidal forces tear the star apart, breaking it into pieces and pulling it toward the black hole. Its remains turn into a stream of debris that falls toward the black hole's accretion disk. However, before the debris settles into the disk, it overshoots the black hole in an elliptical path, only to be pulled back in. At one point in this path, the debris collides violently with other parts of the star being pulled in, and that's when we start to see the first bursts of emissions. In some rare cases, tidal disruption events create huge jets of material that shoot out from the black hole's poles. If these jets happen to point directly at Earth, we can see the signature of the event. It often looks like an intermediate mass black hole eating a white dwarf star. However, there should still be some radio emissions coming from the jet of a tidal disruption event. The reason none have been detected yet might be that the event was likely observed too early. Previous studies suggest that it can take hundreds or even thousands of days for the jet material to slow down enough to start sending out radio signals. If future observations pick up radio emissions, it could help solve the mystery. But if there are no signals, it might mean it's a very unusual gamma ray burst or something completely new that we haven't seen before. Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story – numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars. Attention! Attention! Emergency alert! This is not a drill. The Milky Way is on fire! I repeat, the Milky Way is on fire! Evacuation protocols activated. All terrestrial life forms are to be moved to the Andromeda Galaxy immediately. I repeat! Wait, a fire in our home galaxy? It all comes down to the incredibly hot gas surrounding the Milky Way. This isn't just intensely hot, it's also existed for billions of years. But what's heating this gas and keeping it that way? The Milky Way holds far more gas than stars, and this gas is crucial for forming new stars. Over billions of years, this massive reservoir has allowed the galaxy to keep producing stars. But this gas is incredibly thin and spread out, which makes it next to impossible to observe it directly. For a long time, this made it difficult to figure out how much gas the Milky Way really contains. But in recent decades, researchers finally confirmed that the galaxy is indeed surrounded by an enormous sphere of hot gas. This gas cloud extends as far as 700,000 light-years from the galaxy's center and reaches temperatures of several million degrees. At first, scientists thought the gas's insane temperature was due to the Milky Way's gravity. They believed that gravity caused the gas to swirl around, keeping it from falling inward and heating it up in the process. But then, recently, scientists have discovered something even more surprising: a second layer of gas. And it's even hotter. How did we discover this gas with a temperature of around 18 million degrees Fahrenheit? Faint X-rays coming from all directions in the sky revealed the presence of this gas. The gas also showed up as it absorbed light from distant quasars, bright objects far outside of our galaxy. No wonder scientists began looking for the sources of heat that could explain this bizarre phenomenon. They soon found that the two types of gas, the X-ray emitting gas and the absorbing gas, came from different regions in the galaxy. The X-ray emitting gas is apparently produced by a puffed-up region around the Milky Way's stellar disk. This region is a direct result of the galaxy's star formation, which is still going on. Massive stars in these regions eventually explode as supernovae, releasing huge amounts of energy. This energy heats the surrounding gas to extreme temperatures. The gas heated by supernovae becomes turbulent, moving around chaotically. Some of it escapes into the space around the galaxy, while some of it cools down and falls back toward the disk. This continuous cycle of heating, cooling, and movement keeps the hot gas layer visible in X-rays. The absorbing gas is enriched with elements like sulfur, magnesium, and neon. These elements are created inside massive stars through nuclear reactions and escape into space during supernovae explosions. Runaway stars that are flung out of the Milky Way's disk also contribute to this process. When they explode as supernovae, they create pockets of enriched gas above the galaxy's disk. The X-ray emitting gas forms a glowing layer around the Milky Way's disk. This layer never disappears due to the star formation and supernova activity happening in the galaxy. Together, these processes explain both the absorbing and emitting signals observed by astronomers. Star formation, supernova explosions, and gas movement all work together to shape the Milky Way. The hot gas not only helps regulate star formation, but also redistributes materials created inside stars. And elements produced in stellar cores are spread throughout the galaxy by supernovae, becoming the building blocks for future generations of stars. The research team plans to keep observing the gas at other wavelengths of light. This might give us even more information about how the gas behaves and what it's made of. And once we understand the dynamics of this gas, we're likely to learn more about how galaxies like the Milky Way evolve over time. We need all the data we can collect after all. We don't even know the true shape of our galaxy yet. Recent discoveries have revealed that the Milky Way is not a flat disk as previously thought. No, it has a warped structure. And the craziest thing? Dark matter might be the cause of this deformation. The first confirmation that the Milky Way isn't a perfectly flat disk came from observations by the Gaia spacecraft. Gaia mapped the positions and movements of over 1 billion stars, and its observations showed that the Milky Way extends farther outward than initially believed. At its edges, the galactic disk was a wavy, warped structure with serious deformations along the outer edge. But what causes the warp? These deformations may result from ancient galactic collisions, like the Milky Way's collision with the Sagittarius dwarf galaxy around 6 billion years ago. However, a new study suggests another possibility. The warp might be caused by a tilted dark matter halo surrounding our galaxy. Dark matter halos are invisible, yet massive structures surrounding most galaxies, including the Milky Way. These halos contain most of a galaxy's mass and have a strong gravitational influence on the galaxy's structure. If a dark matter halo is tilted relative to a galaxy's plane, its gravitational effects could distort the galaxy over time. To figure out whether this theory is true, researchers used data from highly detailed computer simulations that modeled galactic evolution, seasoning the process with dark matter and interactions between matter and magnetic fields. The analysis revealed that the inner region of a dark matter halo can indeed tilt significantly with respect to a galaxy's plane. This tilt could result from galactic collisions or close encounters with other galaxies. Such crooked halos can stay this way for billions of years, which is long enough to warp the galactic disk. At the same time, this phenomenon isn't something unique. Astronomers have observed warped planes in other galaxies as well. In fact, nearly half of all spiral galaxies in the universe have warped disks. So, tilted dark matter halos and their gravitational effects might play a widespread role in shaping galaxies over time. While we're looking for answers, the Milky Way continues to shine brightly. But what kind of space electricity keeps its lights on? What fuels the process of star formation? After all, roughly 1 sun-sized star is born each year in the galaxy, and it needs a lot of fuel. Star formation requires hydrogen, the most abundant element in the universe. But it would still have been depleted long ago, unless there were a replenishing source. The source might be fast-moving hydrogen clouds raining down into the galaxy's disk. The hydrogen fueling the Milky Way is ionized, making it challenging to detect. Unlike atomic hydrogen, which emits light, ionized hydrogen does not. Instead, it absorbs light, which means it can only be observed when it passes in front of a bright background source. Before, astronomers used quasars, extremely bright distant space objects, as backlighting to detect these gas clouds. Unfortunately, in this case, it was impossible to determine how far away the clouds were. They could have been located anywhere between the Milky Way and the quasars billions of light years away. To pinpoint the location of the gas clouds, astronomers turned to the cosmic origin spectrograph aboard the Hubble Space Telescope. They observed 27 stars located within 10,000 light-years of the Milky Way's disk. They analyzed the stars' light and found that about half of the stars were obscured by gas clouds. It means they were close enough to directly feed the Milky Way's disk. The researchers calculated that the gas clouds contained a total mass equivalent to a whopping 110 million suns. This vast reservoir of hydrogen offers more than enough fuel to sustain the Milky Way star formation. But where did those clouds come from? So far, it still remains a mystery. There are two main possibilities. The cloud might consist of hydrogen formed shortly after the Big Bang, primordial gas. These structures could have remained outside any galaxy for billions of years, only recently falling into the Milky Way's gravitational pull. Or the clouds might be made of material ejected from the Milky Way itself. When stars explode as supernovae, they can blow gas outward. Over time, this material could cool and fall back toward the disk, forming the clouds. We'll be able to figure out the origin of the clouds only after studying their chemical makeup. Gas from exploding stars contain heavier elements, while primordial gas created after the Big Bang is composed almost entirely of hydrogen and helium. Future ultraviolet telescopes could provide the detailed measurements needed to settle the question.
So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage, but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now, let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, They've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy. an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we? Now see here, astronomers have recently discovered a neutron star, also known as a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe. And it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 12 miles wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of 2 suns and squeezing it into a sphere about the size of a city. A single teaspoon of neutron star material would weigh around 10 million tons. That's the same as the combined weight of 85,000 blue whales. Such an extraordinary density is what gives neutron stars their immensely powerful gravitational fields. When matter falls onto a neutron star, it accelerates to speeds of millions of miles per hour before slamming into the surface. The energy release from such impacts is truly astonishing. Now, despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Now, normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like a neutron gnagi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going any deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penny pasta. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system located in a dense star cluster. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second, but a minute, it'll be over 42,000 revolutions per minute. At the same time, the newbie ties with another neutron star which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait, we can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system, with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. So, you might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. No, accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star's surface, eventually. It triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than our Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and thus confirmed its extreme rotational speed. But wait, the best part is coming. While neutron stars are already extreme, there's another class of them that takes things to a whole new level – magnetars. Now, magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These fields set them apart from other neutron stars. They can distort atoms in nearby objects, making life impossible anywhere near them. As for the energy density of a magnetar's magnetic field, it's so high that it's 10,000 times greater than the mass density of lead. Magnetars also produce bursts of X-rays and gamma rays that are so powerful they can temporarily outshine entire galaxies. These bursts are often triggered by star quakes, violent shifts in the magnetar's crust caused by their own magnetic fields. For example, a gamma-ray burst from a magnetar in 2004 was so strong that it disrupted Earth's ionosphere. It hit Earth, and it was so intense that several satellites picked it up. The SWIFT satellite, built specifically to detect gamma-ray bursts from across the universe, didn't just detect the blast, it got hit with so much energy that its sensors got completely overloaded. And SWIFT wasn't even facing the burst. The energy was so strong it passed through the spacecraft and still overwhelmed its cameras. If a magnetar was located as close to Earth as the Moon, its magnetic field would erase all credit card data on the planet by wiping the magnetic stripes clean. Whoa, that's the level of power we're dealing with here. Magnetars are extremely active, but for a relatively short time. Their intense magnetic fields decay after about 10,000 years. After that, they stop emitting strong X-rays and gamma rays. Astronomers think that there are at least 30 million inactive magnetars in the Milky Way galaxy alone. These silent cosmic relics are scattered all over the galaxy. Neutron stars and magnetars serve as laboratories for extreme physics. They allow astronomers to have insights into the behavior of certain matter under conditions you can never replicate on Earth. The incredible density of these objects helps scientists figure out what happens when protons and electrons get compressed together to form neutrons. This creates states of matter that don't exist over the universe during these energetic events, eventually becoming parts of planets and stars and you and me. Oh, by the way, NASA's NICER instrument has played the key role in uncovering the mysteries of neutron stars. Its ability to detect X-rays with high precision allowed astronomers to study the rapid spin of the neutron star we've been talking about and the thermonuclear bursts that occur on its surface. So, what could be nicer than that? Back in 2008, astronomers found a mysterious something orbiting a star called Fomalhaut. The star is very bright and sits about 25 light-years away from us. Trillions of miles, sure, but pretty close in space terms. It's in the constellation Southern Fish, the one that looks like a single fish floating in the southern night sky. It's a small and relatively dim constellation, but Fomalhaut is what makes it so special. In Arabic, this means mouth of the fish, and you might guess where that name comes from. It's the brightest star in the constellation. If you're in the southern hemisphere, you can easily spot Fomalhaut with the naked eye. For people in the northern hemisphere, it's visible in the fall, low on the southern horizon. But this constellation has a beautiful story. The myth says that this fish is the one that saved the deity Durcedo, who had fallen into a lake. So it became the symbol of rescue and protection. The fish in Pisces is said to be the offspring of the southern fish, forming a kind of family. At the same time, Fomalhaut is sometimes called the lonely star because it's one of the brightest stars in its part of the sky, but it doesn't have many bright neighbors. Hey, I can relate to that. Nah, just kidding. Fomalhaut is also a young star. It's only about 440 million years old. Now that sounds like a lot, but our Sun, in comparison, is 4.6 billion years old. And finally, it's surrounded by a giant ring of dust and gas. This is called a debris disk. It's like a dust cloud that serves as the birthplace of planets. It's like the Kuiper Belt in our own solar system, where Pluto lives, but on a much grander scale. But then, astronomers noticed something odd about this disk. It wasn't evenly shaped. This means that there's something that influences gravity nearby. A planet, perhaps? And when they took pictures of the disk, they found a faint glowing dot inside it. That was our mysterious gravity center, Fomalhaut b, or how they named it later, Dagon. They immediately thought it was a planet. In 2008, it was a huge deal because scientists captured an actual image of it using the Hubble Space Telescope. Now that's a super rare thing, especially for objects outside our solar system, not to mention such tiny things as planets. And the photos were fascinating. At first, everyone was excited about the new world. Scientists thought that Dagon was a massive planet, something maybe like Jupiter, a gas giant. They even guessed that it had an oval-shaped orbit, which means that it would take about 1,700 years to go around its star just once. That's one of the craziest orbits we've ever seen. But as they kept studying Dagon, they noticed that things don't add up. For starters, they couldn't find it in infrared light. Now, planets that big usually give off heat, and telescopes like Spitzer, which look for heat signals, found nothing. Weird, right? Also, the planet was moving too strangely. Its orbit didn't match what you'd expect if it were shaping the dust ring. So scientists started thinking, maybe it's not a planet at all. And as the doubts creeped in, the hype calmed down. In 2020, they noticed another strange thing about Dagon. It was getting dimmer and spreading out. And well, planets don't usually do that, but clouds of dust do. This led to a new idea. What if Dagon isn't a planet, but the result of a massive collision? Imagine two big chunks of ice or rock smashing into each other at incredible speeds. That's what they think happened here, a giant space crash that led to lots of debris. That's how it got officially removed from the list of exoplanets. But then, in 2023, the new James Webb Space Telescope, which is even more powerful than Hubble, decided to take a closer look at Dagon. And when scientists looked at the data, they jumped back into the previous debates. Wait, it might be the planet after all. All this scientific back and forth led to Dagon getting dubbed the zombie planet. But after a while, astronomers finally found the middle ground. Dagon really turned out to be a dust cloud that's slowly disappearing, but there could still be hidden planets in the system. There's another ring of dust closer to the star that might be shaped by an unseen planet. There are many mysterious weird planets out there. Trace 2b orbits a star 750 light-years away from Earth, much farther out than our Dagon. It's in a region of the sky that's been heavily studied by planet hunters. It was first discovered in 2006 by the Transatlantic Exoplanet Survey, an observatory with a bunch of cool telescopes that are used to find planets. They use a witty method for it. They observe the stars, and when they see unexpected dips in brightness, that means that something must be passing in front of the star, making it a wee bit darker. This is called the transit method of the planet discovery. When Trace 2b was spotted that way, scientists took a closer look and confirmed it. It had a certain gravity pull that caused its star to wobble. But that also means that the planet should be gigantic, probably a gas giant like Jupiter or Saturn. But, unlike Jupiter, Trace 2b is much closer to its star. This makes it a special type of a planet called hot Jupiter. That's what we call gas giants that orbit so close to their stars that their atmospheres are scorched to extreme temperatures. Imagine if Jupiter was not only horrifyingly massive, but also almost burning. This planet is tidally locked to its star. This means that it always faces the sun with one side, just like we can only see one side of our moon. Its day side is blisteringly hot, but even the cooler night side has temperatures around 2,900 degrees Fahrenheit. But there was something very eerie about this new world. What really made it stand out was its albedo, a measure of how much light the planet reflects. Most planets, like Jupiter or even Earth, reflect a good amount of light thanks to clouds, ice, and other stuff. This is what allows us to see those planets after all. But Trace 2b is almost completely black. For some reason, it reflects less than 1% of the light that hits it. It's darker than coal or fresh asphalt. So, why is that? After some thought, astronomers think it might be because of its atmosphere. Jupiter has bright reflective clouds of a gas called ammonia, but Trace 2b probably doesn't have those. Since it's so close to its star, they'd burn up and get stripped away. So, its atmosphere might be made up of chemicals like sodium, potassium, or titanium oxide. All of this stuff absorbs a lot of light, and if you look directly at that planet, you'd see it almost as a black hole. What's even more horrifying is that if you were floating in it, since it doesn't have a solid surface, these elements could make the sky above look like an endless void, even if it's daytime. Though you'd probably still see its star, even it would be completely surrounded by blackness, like light at the end of a tunnel. In that case, shouldn't it be completely invisible? Well, it kind of is. But it also emits a faint red glow, likely due to its scorching high temperature. And even though scientists have studied Trace 2b for years, some questions remain unanswered. Why is it the darkest planet we've ever found? Is it possible that there are some unknown chemicals in its atmosphere? What hides beneath the darkness? These Jupiter-like planets are often crazy, like WASP 76b, for example. This is another gas giant located about 640 light-years away, this time in the constellation Pisces. Just like Trace 2b, this exoplanet is tidally locked. One side has a temperature of over 4,000 degrees Fahrenheit, while the other side remains in constant darkness. But what's crazy about it is that the extreme heat on the day side vaporizes metals like iron. The planet has insanely strong winds, and they blow this molten iron to the colder side. And you guessed it, the iron gets solid under colder temperatures, and we end up with a horrifying iron rain. All this stuff sounds like science fiction, but it's real, waiting to be explored.
At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. Only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard World Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across 2 black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri e, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, The year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri E had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Cancri E might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Cancri E, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pulsar, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pulsar in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where two massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets, like co-Rot 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tres 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve as a reminder of how much we have yet to learn about the universe.
Right after its creation, the cosmos was shrouded in darkness. I mean, I wasn't there, but that's what most scientists are thinking. All of the stars were hidden behind a thick cloud of primordial gases. Then, all of a sudden, something cleared up this fog, and the universe started shining as it finally woke up. But how did this happen? 8 faint, recently discovered galaxies might hold the answer. The Big Bang created our world around 13.8 billion years ago. At first, it was just a super hot and chaotic boiling soup of particles. But over time, things cooled down, and particles could finally stick to each other. That's how the atoms appeared. Some helium, but mostly hydrogen, the very first element. And these first elements started creating thick gas clouds, which were very opaque. Then the first stars started forming. They were incredibly bright, emitting lots of light, including ultraviolet radiation. But even though these stars were shining, much of their light couldn't travel far because of that nasty hydrogen fog. The gas clouds absorbed and scattered any little light particles around. It was like the light was trapped around the stars. The Dark Ages lasted for hundreds of millions of years. Then, everything changed. Recently, the James Webb Space Telescope has spotted ancient dwarf galaxies from that epoch. Turns out, they're the ones we should be thanking for lighting up the universe. Back then, they were filled with early stars. These stars emitted tons of radiation that was so powerful that it managed not to just overcome, but break apart the hydrogen atoms in the fog. It turned them into charged particles, like particles that carry a little bit of electricity, called ions. Little by little, the fog was cleared away. This process of clearing out the fog is called reionization, and this beautiful time is known as the epoch of reionization. Finally, the light was able to travel to all corners of the universe, which was a game changer, just like humans' Age of Enlightenment. To find these little igniters, astronomers used a technique called gravitational lensing. Imagine light traveling through space like a straight beam. But just like everything in our world, even time, light obeys gravity. If it's too strong, it'll literally bend the light beams. So when the beams pass near a massive object, the object's gravity pulls on them, curling and twisting their path. That's why black holes look so creepy, as they stretch stars and space around them like some whirlpools. But it's not that creepy. A regular glass or magnifying glass does something similar, hence the name gravitational lensing. When the lensing object is horrifyingly massive, it bends the light into multiple images of the same object, creating a creepy and mesmerizing structure called an Einstein ring. But if it's not that big, then the bending is less dramatic, and it just slightly distorts the shape of the background object, making it look kinda stretched. Gravitational lensing also helps scientists study things like the spooky dark matter. If the light looks stretched, and it's not just because of some obvious massive objects nearby, then it might be something invisible and heavy bending it. Since these 8 galaxies were too faint, no wonder they're almost as old as my unread emails. Scientists had to use these gravity tricks to observe them. The team studied light from galaxies that are over 13 billion years old. Finally, they focused on a galaxy cluster called Abell 2744, also known as Pandora's Cluster. And these findings helped them understand how even little fellas played a huge role in transforming the early universe. The James Webb Telescope is an incredible tool, and soon it might help us look at even earlier times, at the cosmic dawn, when the universe was only several millions of years old. Another great tool, called the Roman Space Telescope, is going to help it. It's also possible that these galaxies weren't the only helpers in this entire saga. These early massive stars were absolutely terrifying. They just don't make them like that anymore. Some estimates suggest they were 30 to 300 times more massive than our Sun, and millions of times brighter. Modern stars have some heavier elements in them, but back then, they used only the stuff available, hydrogen and helium, which is why they were so hot and shiny. But they also had very short lifespans, lasting just a few million years. For example, our Sun is 4.6 billion years old and is still going strong, thankfully. At the end of their lives, they went supernova. These colorful bursts of energy were so strong that they forged the first heavier elements in our world and spread them across the universe, planting first seeds for the future planets. Meanwhile, the stars themselves didn't just disappear. They collapsed under their own gravity, creating the first black holes. Now, the black holes are also known for producing insane amounts of radiation. So it's possible that they might have helped speed up the clearing of the fog. Ironically, they help the universe shine brighter while sucking up the light at the same time. Recent discoveries show that black holes might be much older than we used to believe. They probably helped new stars and galaxies form. They were millions or even billions of times the mass of the Sun. The James Webb Telescope has already found a pair of early quasars. That's what we call the bright centers of galaxies powered by supermassive black holes. It's a curious pair of quasars that are merging just 900 million years after the Big Bang. This might be the earliest and most distant pair of merging quasars ever found. The telescope has also been studying things that are called cosmic lighthouses. In scientific language, they're pulsars. Pulsars are super-dense remnants of massive stars. They form from stars that were once 4 to 8 times more massive than our Sun. One of the greatest things about them is how fast they spin. They're one of the fastest objects in the universe. They might do around 700 rotations in just 1 second. They got their name because they behave like lighthouses, basically flickering radio waves. These beams of radiation sweep across the sky, creating a pulse-like signal that we detect. Now, a star basically works like this. There's nuclear fusion happening inside of its core. Atoms get fused in each other, move at crazy speeds, bump, all meanwhile releasing an unbelievable amount of energy. That's why they emit tons of light and heat. Of course, all this pressure tries to push outward, sweating like crazy to expand a star. The greatest the fusion is, the more powerful and insane the star gets. On the other hand, there's gravity that's pulling inward, trying to compress the star and keep it a nice small dense ball. As long as there's balance, the star keeps living. But when it gets old and spends all of its nuclear fuel, it becomes too weak to generate the energy it needs and can't fight against gravity anymore. That's when it basically collapses under its own weight, going supernova. What's left behind is the star's core, but now it's crushed down to an incredibly small size, about 12 to 17 miles across. It's roughly the size of a city. This dense core is known as a neutron star. The material in a neutron star is so dense that just a teaspoon of it would weigh as much as 4 billion tons, like 10,000 Empire State Buildings. And all this collapse sets off a trigger, causing the neutron star to spin super fast, creating a pulsar. It's kind of like when an ice skater spins faster when they pull their arms in. Pulsars often have a smaller star friend orbiting them, although it's not always a friendly relationship. Not long ago, astronomers discovered a pulsar that was surrounded by lots of energetic material for some reason. They realized that all this material was the remnants of another much larger star. Turns out, the pulsar had been slowly destroying its friend with its terrifying radiation and particles until it basically ate the neighbor away. It's similar to how a black widow spider consumes its mate. So, systems like this were called black widow pulsars. In any case, these lighthouses most likely help the reionization process as well. A long time ago, they could be very energetic stars in small galaxies and could emit enough radiation to transform the early universe. The James Webb Telescope's mission is to find more of these lighthouses and see what role they played in the universe's evolution.
The first computer that resembles the machines we use today was invented back in the 19th century. It already seems much earlier than you probably thought, but there was an even older prototype. The Antikythera mechanism was invented by the Greeks over 2,000 years ago. Over a century after its discovery, scientists might have finally solved its mystery. Sponge divers accidentally found the Antikythera mechanism on the bottom of the sea of the Greek island of Antikythera at the very beginning of the 20th century. It was one of the many ancient treasures from the shipwreck of a Greek trading ship that probably set sail around the year 60 before the Common Era. There were marble statues and jewelry, beautiful glass bowls, rich furniture, and one mysterious device. It had a case made of a corroded clump of metal and was the size of a large dictionary. The sponge divers didn't know what to do with it and took this strange item to the National Archaeological Museum in Athens. Months later, The lump broke apart and it turned out that a real architectural gem was hiding inside. It had at least 30 gears, and there were traces of many more that hadn't survived. The mechanism was just sitting there for 50 years before historians finally decided it was worth their attention. The big brains who worked with it thought it was a super complex astronomical calculation machine from over 2,000 years ago. They couldn't believe it could have been made in ancient Greece or anywhere else in the ancient world. The tech behind the gadget was centuries ahead of its time. Over the decades, different scientists have been trying to solve the mysteries of this super advanced device. They've used X-rays, CT scans, and all sorts of fancy tools. They thought it could have been a navigation device, or even some kind of time travel contraption. Some of them even believed it wasn't from our planet. In 2021, a team of scientists presented a computational model that showed how this unique contraption might have worked. According to them, it was like a tiny ancient supercomputer, covered in Greek inscriptions with some astronomical secrets hiding in them. The Greeks probably used it for tracking the positions of the sun, the moon, and lunar phases with a half-silvered ball. The way the moon moves in the sky is really tricky to copy. To do it, whoever created the mechanism used a very clever system with special gears and a slot and pin mechanism. These gears, called epicyclic gears, work together in a complex way. The slot and pin help to make tiny changes in the moon's movement. If you flipped over the mechanism, you'd see some groovy dials, including one with a spiral slot that tracked lunar months. They were used to keep those calendars in check. There was also another dial that predicted solar and lunar eclipses, like some cosmic fortune teller. Depending on which display you were looking at, you could see all of these different functions, so it was pretty much like an ancient tablet. The main theory is that the mechanism was made in a workshop on the island of Rhodes. It could have been a fancy order for a rich customer from northern Greece, and that's how it could have ended on the trading ship. Some people think that the device was the creation of the legendary mathematician and inventor Archimedes himself. But he had lived a couple of centuries before this particular Antikythera mechanism was created. So he could have invented the concept, but couldn't have created this very device. He might have started with a simpler version and then refined it over time, using the latest knowledge of astronomy. Because the Antikythera mechanism is the only physical remnant of many mechanical astronomical displays from the past, we have nothing to compare it with. It might not let its users travel back and forth in time, but it sure could predict astronomical events in the future. The ancient Greeks didn't create it to do work. They were trying to model the skies. It doesn't look like they needed it for navigation, so another theory is that they could use it to create horoscopes. But then again, it was way too complicated for such an entertaining purpose. It sounds more like it was some kind of a philosophical and educational tool. It had in one place all of their knowledge of the universe and how it works that was available at its time. The inscriptions on the mechanism weren't some instructions for experts. They were made for everyone to easily understand them. The latest news about the Antikythera mechanism is that scientists from the University of Glasgow used some special math methods on it. They wanted it to figure out how many holes were in one of its broken rings. They found new proof that one part of the Antikythera mechanism was probably used to keep track of the Greek lunar year. In a new paper they published, the scientists shared that they found that the ring probably had 354 holes. This new research was sort of inspired by a YouTuber who collected data on the mechanism. He was trying to make a copy of the calendar ring and was looking for ways to figure out how many holes it had. To solve this mystery, co-authors of the new study used a special math method called Bayesian analysis. This method uses probability to figure out uncertain things based on incomplete information. They looked at the positions of the holes that were still there and the placement of the 6 surviving pieces of the ring to calculate the likely number of missing holes. Now, they're more sure than ever that the ring had either 354 or 355 holes, not 360 holes, which some earlier studies had suggested. The second co-author of the study used the same techniques that normally analyze the signals from the gravitational wave detectors. These detectors measure tiny ripples in space-time caused by massive events like black holes colliding. The results were really detailed and showed the same number of holes as the mathematical method. The holes were placed with amazing accuracy, with only a tiny average difference of 28 thousandths of a millimeter between each hole. Professors behind the study were really impressed with this, as the ancient Greeks had to measure very accurately and have a very steady hand to punch the holes so precisely. So, it looks like the previous studies that had suggested the gadget used to track the lunar calendar must have been correct. No matter what it really was, the mechanism changed our understanding of how advanced the ancient Greeks were. We knew they had built the Parthenon and the Lighthouse of Alexandria even earlier than they created the device, but this one takes them to a whole new progress level. Some things are still not clear about it, like why it took so long for scientists to catch up and invent something as sophisticated as this ancient marvel. Perhaps there's still some gaps in the historical record. Another question is why we haven't found more of the same unique advanced mechanisms. This could have a practical explanation, as bronze was a precious material back in the day of the mechanism. So, when one contraption stopped working, people probably melted it down for its valuable materials to reuse them. Or maybe there are more ancient computers hiding at the bottom of the ocean and we have yet to discover them. Most researchers have agreed with the results of the new study, but there is one who doesn't. Mechanical engineer Tony Freeth, who is an expert on the ancient computer, believes the conclusion of the study is just wrong. He claims the gadget already has one lunar calendar that is more precise than this one. Looks like, although we are one step closer to solving the Antikythera mechanism mystery, the hunt for the truth is still far from being over.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and is called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
Chebysky's star was discovered in the 1960s. Since then, astronomers have been intrigued by its unique chemical makeup. The star is suspected to contain ultra-rare elements, verging on the almost impossible. Using special equipment on the European Southern Observatory's telescope in Chile, researchers took readings of the star's magnetic field. They discovered that the star's rotation period, which is the time it takes to finish one revolution on its axis, stretches out over almost 200 years, which is super slow. Of course, there are even more bizarre objects called apstars. They're a chemically interesting category of stars that rotate extremely slowly, with one rotation taking up to 1,000 years. What makes these stars even more peculiar is a wide range of chemical elements astronomers detect when analyzing their stellar spectrums. But if we look at Chebysky's star, we'll see that it's both similar to and different from other apstars. It contains unusually low amounts of iron and nickel. Our Sun has 10 times more and incredibly high amounts of rare, heavy elements. Those might include strontium, cesium, and neodymium, as well as at least 2 undiscovered elements. They wouldn't occur through any natural processes we currently understand. There's a hypothesis that the presence of such heavy elements could be caused by a star's unseen companion, like a neutron star. Some people go as far as to say that such an incredible chemical makeup could be a sign of an alien technosignature. Any specialist will tell you that it's the strangest stellar spectrum they've ever observed. Some even claim that there are so many chemical indicator lines you can't immediately understand what you're looking at while observing the star's spectrum. Chebysky's star also contains high levels of radioactive elements that take a few thousand years to decay. And here's where another mystery lies. They should have long vanished from the star. After all, it's almost 1.5 billion years old. Scientists haven't managed to figure out the reason for the presence of these elements yet. Maybe it's the combination of the star's rare qualities. It spins very slowly, it's hot, and it has a strong magnetic field. This could raise to the surface atoms that would normally be mixed inside the star. There's another theory that explains the presence of these radioactive elements. They could be there as if they were themselves decayed forms of ultra-heavy elements that we haven't discovered yet. So far, no one has been able to prove this theory. Even the discovery of Chebysky's star's super slow rotation doesn't bring us closer to the answer. It's obvious that there's a lot to learn about the bizarre star, and who knows which secret it still has up its sleeve. Another not less mysterious star is called Tabby's star. It's a sun-like orb around 1,500 light-years away from Earth, sitting in Cygnus the Swan. Unlike our Sun, this star dims randomly by 5 to 22%, and it lasts for days at a time. The reason could be a giant planet passing in front of the star, but then the eclipses would be more regular and not so random. And if it was a Jupiter-sized planet, it would also need to block around 1% of the star's light, which would make it unique and unlike anything we know. After American astronomer Tabitha Boyajian discovered the star's massive and irregular fluctuations in 2015, Further observations followed. They show that the overall magnitude of the star has been gradually dimming over the years. Some theories trying to explain this phenomenon are quite believable. For example, some scientists think that these brightness changes are intrinsic to the star. They could be caused by its magnetism or changes in heat flow in its interior. Other ideas are more daring, including some kinds of activity of an extraterrestrial civilization. One of the most plausible theories, though, is that the dimming is caused by the chunks of an orphaned exomoon. It could have been pulled away from its parent planet by gravitational interactions with Tabby's star. As the moon approached the star, it exploded, sending dust clouds into stellar orbit. These countless chunks of rock and dust are now moving between Tabby's star and Earth in a giant, clumpy cloud. It could indeed explain why we observe such irregular brightness variations. Usually, when astronomers spot a spiral arm structure, it turns out to be a galaxy. But not in this case. SAO 206462, located 460 light-years away from our home planet, is a young star. It's surrounded by a circular disk of gas and clearly defined spiral arms. The bizarre star was spotted during an exoplanet search with the help of the Subaru telescope located in Hawaii. Instead of finding fully fledged planets around a young star, astronomers discovered planets that were still in formation. These baby planets are growing out of the disk of gas and dust surrounding the star. The disk extends out to around 80 astronomical units, which is twice the orbit of Pluto. At least 2 of these planets have stretched the disk into its extremely unusual spiral shape. A different planet is responsible for each arm. In our home galaxy, there's a giant star that is a real stellar wind machine. At the moment, this monster is just waiting to burst and send a wave of radiation and hot gas towards Earth. All because it's a Wolf-Rayet, a star which is at that precarious point before it goes supernova. Its core doesn't have any more helium left to burn. Instead, the star is forced to churn through much heavier elements, for example, oxygen. Unfortunately, it disrupts the careful balance between gravity and fusion, leading to the star shedding its layers. When the oxygen eventually runs out, the star will go supernova. But this time, the show will be different. The thing is, WR104 is 1/2 of a binary pair, which means that 2 stars are feeding into each other, spinning up their stellar winds. It will continue until they start going incredibly fast. Is the potential explosion going to harm Earth? On the one hand, we're far away enough for even a directed supernova to not hurt our planet. At the same time, there's a threat of an extremely dangerous gamma-ray burst. Luckily for us, it takes a very specific and unlikely train of events for a Wolf-Rayet to produce a gamma-ray burst. Plus, even if it does, the star might be pointed far away enough for the danger to miss us. Anyway, astronomers are still watching the star, just in case. A star sitting in the constellation of Centaurus keeps a secret not many know about. At first glance, it looks like a dim white dwarf, but when astronomers analyzed it, it turns out to be incredibly dense. Take the mass of the Sun and cram it into something that is only 1/3 the diameter of Earth. This space wonder is also rather cool. Its core temperature is a mere 11,900 degrees Fahrenheit. For comparison, the Sun's core temperature is around 27 million degrees Fahrenheit. At such low temperatures, stars begin to vibrate. And then, scientists can use these vibrations to sneak a peek inside a star. And in the case with the star in question, which was later named Lucy, they discovered that its carbon core had crystallized. In other words, it formed a giant diamond 10 billion trillion carats in size. Since the discovery of Lucy, a few other crystallized stars have been spotted. Some of them have diamond hearts the size of our planet. The last bizarre star for today is called Vega, and it's squashed. The star's bulging waistline is caused by an extremely high spin rate. Vega rotates once every 12.5 hours. This pushes the material around its equator outward. It also leads to the phenomenon known as gravity darkening, when stellar material further from the center of the star experiences less gravity, which makes it cooler and darker. So when Vega faces Earth pole end on, it looks perfectly round. but the dark halo around its middle is a telltale sign of Vega's oblate shape. The universe is expanding faster and faster, but not all scientists agree on the reason. The main theory is based on dark energy, a mysterious something influencing the entire cosmos. But an alternative idea states that our universe might be growing after continuously colliding with smaller, baby universes. Let's try to figure it all out. The cosmic microwave background is leftover radiation from the Big Bang. While examining it, astronomers realized that our universe is going through accelerated expansion. This observation had to somehow fit with the main theory of cosmic evolution. So scientists suggested that the universe was filled with an enigmatic substance that was later dubbed dark energy. They thought this energy could encourage the expansion. Strangely, this elusive form of energy can't be detected in any way. That's why many astronomers question its existence and try to explore other possibilities for the expansion of the universe. One of the more daring ideas is that our universe is growing by constantly merging with other universes. The idea of multiple universes interacting with one another isn't new, but the newest study has developed a mathematical model. It can help us explore the hypothetical impact of such an interaction on the evolution of our universe. According to the researchers' calculations, merging with other universes could indeed increase the volume of our universe, and our instruments could actually perceive it as the universe's expansion. The researchers also claim that their calculations fit with the observations of the universe more closely than the traditional standard cosmological model. It also deals with the problem of the super rapid expansion that happened in the early moments of the universe. Previously, physicists proposed that this expansion could be caused by the inflation. That's a hypothetical field driving the ultra-rapid expansion of the universe in the very first milliseconds after the Big Bang. However, the authors of the new study suggest that super-rapid early growth could have been the result of our baby universe being absorbed by a larger one. At the moment, there is no detailed description of what such a process could look like, so it's difficult to judge if such a scenario could actually take place in the early days of the universe. But if this idea turned out to be true, then there would be no need for an inflation field. After getting absorbed, our newly enlarged universe might have continued colliding with other smaller and younger universes, incorporating them as well. This theory allows us to solve some pretty important problems of modern cosmology. Unfortunately, only observational data can prove whether it's correct. At the moment, many experiments are being carried out to study the properties of the microwave background and find some proof. So maybe we'll get our answer soon. Speaking about the expansion of the universe, we can't but mention the dark flow theory. In 2008, scientists discovered that a few galactic clusters were heading in the same direction at a speed of more than 2 million miles per hour. Could it be something giant and invisible calling them? It might be literally anything. A super large chunk of matter with strong energy, or some weird bending in space-time with insanely powerful gravity that actually comes from other universes. At the moment, the clusters seem to be moving along a line extending from our solar system towards Centaurus. But the direction of this movement is kinda uncertain. Most data indicates that the clusters are moving outward, but some scientists say that the opposite flow can't be ruled out yet. The dark flow theory is pretty controversial, since the distribution of matter in the observable universe can't explain it. The existence of this flow suggests that there's something beyond the visible universe that's pulling on the matter in these clusters. Now, let's dwell on the theory that tries to explain what can be found at the edge. This one talks about multiple universes. Some experts think that our universe might be a very small bubble somewhere in the middle of a whole array of other bubbles. The idea states that, from time to time, all these bubbles can come into contact with one another. Gravity can flow between them and make a mess, and when they connect, a new Big Bang can happen. We've never sneaked a peek beyond the edge of the observable universe. If we managed to get there, we could probably find another universe. There's an idea of parallel universes. Each of them looks exactly the same as our universe, and still, some details differ. In one of them, instead of choosing our current profession, you started a music band or became a world-famous chef. Maybe one infamous asteroid changed its trajectory, and dinos are still roaming Earth in that universe. But the multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities with different life stories. We live in a bubble that is just one of many other bubbles. It looks like bath foam, and these bubbles constantly bob up and vanish. Multiverses are described by a few scientific theories that mention various possible scenarios, from separate universes that keep springing into existence all the time, to regions of space that are in different planes than our home universe. But there's one thing these theories agree upon. All of them suggest that the space and time we observe is not the only reality. It's impossible to explain all the quirks of our universe if it's the only one to exist. So it's either inventing newer theories that can shed light on certain properties of our universe, or accepting the fact that we're living in just one of many, many universes, all of which are different. One of the most widely known universe theories is called inflationary cosmology. This is the idea that right after the Big Bang, the universe expanded extremely fast and exponentially. Such rapid inflation could indeed explain loads of the properties of the universe we observe, like the distribution of galaxies. When this theory was suggested for the first time, it was perceived as science fiction. But with time, people started taking it seriously. Now, the theory claims that inflation might happen again and again, maybe even infinitely. And this could create constellations of bubble universes. Of course, none of these bubbles will have the same properties as ours. There may easily be places where physics as we know it doesn't exist. But even though some of these universes might look like ours, they all lie beyond the realm we can observe directly. There's also another theory, the many worlds interpretation. This one claims that there might be multiple branching timelines or alternative realities. And in each of those realities, our decisions play out differently, which means different outcomes. At the same time, the only reality you can perceive is the one where you live. If it's true, then the question is, where are all those other universes? Well, they most likely overlap in dimensions we absolutely can't access. And at the moment, it's not possible to travel between universes and dimensions. But maybe a few thousand years later, people will not only find a way to prove that parallel universes exist, but also invent a method to hop from one to another. Unfortunately, so far, there's no solid evidence that multiple universes are somewhere out there. All the proof we've got today is purely theoretical. Some experts even argue that it could be an unbelievable cosmic coincidence that the Big Bang created such a perfectly balanced universe as ours. Or, if parallel universes do exist, we might have just inhabited the one that had all the right conditions for our survival. It's still unclear whether the multiverse theory is even testable. Perhaps we just haven't thought of the right tests yet. Now, think about this. What if at one point you stopped existing in your home universe? I mean, the one you were born into. Then your consciousness was transported to a parallel universe. And that's where you're stuck now, watching this video. Write in the comments whether you think it's possible. Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter, about 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow, didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are 2 ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when two magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars and the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with two blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, my Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old, and from what we can see, one mysterious star, HD 11402883, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is. At least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious. but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
So get this, Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space, we're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the Rosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
Let's take a little satellite, tie it to the shuttle with 12 miles of cable, and send it for a spacewalk. It might sound like another crazy plot for a YouTube hit video, but this idea actually belonged to NASA. In 1996, they teamed up with the Italian Space Agency to try one of the boldest, strangest experiments ever attempted in orbit. The mission was called TSS-1R, short for Tethered Satellite System 1R. They came up with a plan to reel a satellite from the Space Shuttle Columbia on a tether that could carry an electric current. As the shuttle zipped around Earth, that long cable would slice through the planet's magnetic field lines. In physics terms, moving a conductor through a magnetic field generates electricity. So, the Space Shuttle Tether Satellite combo was about to turn into a giant orbital power generator. It was like plugging an extension cord into Earth's invisible magnetism. The physics behind this craziness was rock solid. Engineers hoped this tether would pump out usable power, maybe even thousands of volts. If it worked, it could change how spacecraft get electricity or inspire new ways of braking in orbit using electrodynamic drag. So, launch day came. Columbia lifted off. The crew prepared the system, and they started letting the satellite out on its long, long cord. At first, it was smooth sailing. The satellite glided away, the tether unreeled like a spool of cosmic fishing line, and the science team was buzzing with excitement. As the line stretched longer, it started generating more and more electricity, over 3,000 volts at its peak. Everything was running perfectly like a dream experiment. And then, just as the tether was almost fully extended, nearly the full 12 miles, things took a dramatic turn. A localized electrical discharge zapped through the tether's insulation. The cable arced and burned a hole right through itself, and with one fatal snap, the tether broke. Just like that, the grand experiment was toast. The crew could only watch as the little satellite, still trailing its dangling wire, floated off into space like a lost balloon on the world's longest string. Years of hard work preparing the experiment just literally drifted away. Visually, it was almost comical. Reporters couldn't resist calling it the goofiest space experiment in history, and honestly, they weren't wrong. It looked less like cutting-edge space technology and more like someone had tied a toy to a string and let it loose above Earth. But, goofy or not, the experiment actually proved the physics worked. Before the failure, the tether really did generate significant electricity, exactly as the scientists predicted. Over 3,000 volts coursed through that cable before it fried. The idea of using conductive tethers for power and propulsion in space wasn't a fantasy. It was all real. The problem wasn't the science, it was the engineering. Space is an unforgiving place, and one small weakness in insulation was enough to take down the whole mission. Even though TSS-1R ended with a literal snap, it left behind valuable data. Engineers learned more about how tether systems behave in orbit, and the concept is still alive today. Researchers keep looking at space tethers for everything from satellite deorbiting systems to futuristic power stations in orbit. So that broken cable might have been a letdown in 1996, but it wasn't the end of the story. If a satellite on a cable isn't wild enough for you, how about two golden orb weaver spiders on the International Space Station? In 2011, NASA sent these two cuties, called Gladys and Esmeralda, up there on Shuttle Endeavour, just to see, can spiders spin webs in microgravity? Turns out, yes. The experiment lasted 45 days. While floating in orbit, the spiders went ahead and spun webs, but the webs looked shockingly symmetrical, perfect circles, rather than the slightly lopsided webs they usually make on Earth. The spiders, deprived of down and up, used light inside their habitat to orient themselves. On Earth, spiders use gravity to guide how they stretch their legs and spin out their web lines. But in space, with no gravity to rely on, they looked at the lamps and used that as their ground. But that experiment in 2011 wasn't the first space adventure for spidernauts. Way back in 1973, NASA launched 2 female European garden spiders called Arabella and Anita into space aboard Skylab 3. The idea of this experiment actually came from a 17-year-old high school student in Massachusetts. The spiders were stashed in little containers and then coaxed into a special tank to spin webs while orbiting Earth. At first, Arabella struggled. She took a while to adapt, and the first web she spun was incomplete. But by the next day, she managed to finish it. Over time, the webs she produced were finer and more delicate than normal Earth versions, and scientists noticed subtle differences in thickness across the threads. But NASA wasn't just curious about spiders for the sake of, spiders. Scientists wanted to figure out how near microgravity messes with the central nervous system, not just in spiders, but in animals in general, humans included. Spiders actually make the perfect test subjects because their webs are basically brain maps in silk. You can tell how well the spider's nervous system is working just by looking at the shape and quality of the web it spins. On Earth, a spider has a whole toolkit. It knows how heavy it is, so it figures out how thick the silk needs to be. It uses wind and gravity to decide where to anchor and how to stretch the lines. But the way spiders adjusted to build webs in 0G gave clues about how our own motor systems and brains might behave if we had to live long-term in space. Sadly, Arabella and Anita, the first 2 spidernauts, did their job, spun webs, gave us tons of data, but didn't survive their mission. The likely cause was dehydration. On a brighter note, scientists have grown everything from lettuce to yeast on the ISS. But one of the oddest was trying to see if fungus could shield astronauts from radiation. They took samples of a fungus that thrives in places with high radiation and monitored how it reduced radiation passing through it. Over a thin layer of this fungal mat, radiation levels dropped by about 2.17% compared to a control sample. At the same time, the fungus had around a 21% growth boost in microgravity. So not only did it block some radiation, it actually seemed to use radiation to fuel itself, almost like a weird fungal solar panel. Now, you might ask, why fungi? Why not steel or lead? Because living things self-repair, self-replicate, and adapt. If you could grow stuff that helps shield you from radiation while it's doing other jobs like repairing and evolving, that's gold for long space missions. The idea is, maybe astronauts could grow part of their radiation shield using organisms, instead of hauling tons of heavy shielding materials into space. There was also broader research catalogs on space fungi and microbes. One study in 2019 cataloged all the bacteria and fungi found inside the ISS, on walls, equipment, windows, sleep stations, you name it. They found the fungal communities were pretty stable over time. That means fungi are not just surviving, but persisting in that closed, harsh space environment. This science experiment is like a hint that we could have a future where biology and engineering mash together. If we can harness fungi or other organisms as part of a spacecraft structure, we open up a whole new way of designing space habitats. Instead of walls you build once, you could have walls that grow. To make radiation levels Earth-like on Mars, you might need a 7.5-foot thick layer of this fungus covering a habitat. That's huge, but maybe easier than dragging tons of lead through space. There's a lot to figure out about safety, control, dose limits, and how this would work long-term. But in the future, astronauts might live behind walls of living mushroom shields, literally harnessing biology to survive the void. You look up at the night sky and see nothing. Okay, well, it's not nothing. You see stars, but not nearly enough. If the universe is filled with endless stars in every direction, why isn't the sky blazing with light? That's just one of many cosmic riddles that are still waiting for an answer. Why do black holes delete information? Why can't the universe agree on how fast it's expanding? Yeah, these paradoxes break rules so much that it feels like they're breaking reality itself. The universe is endless, right? Just stars on stars on stars stretching out into infinity. Well, if that's the case, then how come the night sky isn't lit up like Times Square on New Year's Eve? That's the heart of Olbers' paradox, named after 19th century astronomer Heinrich Olbers. He wasn't the first to notice the problem, but he made it famous by basically asking, if there are stars in every direction, shouldn't the whole sky be glowing? You might think they're just too far. But in an endless universe, every direction should eventually hit a star, and all that faint light should add up. So, why the darkness? Maybe the answer is that the universe isn't infinite in time. It had a beginning, the Big Bang. That means light from the most distant stars hadn't had enough time to reach us yet. And the light that has been traveling for billions of years, it's been stretched out so much by the expanding universe that it's now invisible to our eyes. So, that pitch black sky? It's not empty. It could be that it's full of light. We just can't see. Maybe it's a clue, a sign that the universe has a beginning, a history that we have yet to uncover. Alright, so space is darker than it should be. But you know what's even weirder? It's also way too quiet. You probably wondered about this since elementary school. Okay, the universe is massive. There are billions of stars with planets orbiting them, and a bunch of those planets should be kinda like Earth, which means extraterrestrials, right? So, where are they? This is what we call the Fermi paradox. Back in the 1950s, physicist Enrico Fermi sat down and asked himself this very question. There are no signals from outer space, no laser beams, no weirdly coded messages, nothing. It's not like we haven't tried to say hello. In 1974, scientists used the giant Arecibo radio telescope to beam a binary-coded message into space. It included stuff like our DNA structure, a stick figure of a human, and even Earth's location in the solar system. And since sound can't travel in space, what we actually sent were radio waves traveling at the speed of light. The message is heading to a star cluster 25,000 light-years away. So even if those little green men pick it up the moment it arrives, the earliest we could get a response is in about 50,000 years. Okay, that's pretty far into the future. But wait, if we're out here sending signals, isn't it possible someone else did the same, like 150,000 years ago, or 500,000? Shouldn't something have reached us by now? Some extraterrestrial TikTok at least? The answer could be that we're the first technologically advanced civilization. Perhaps intelligent civilizations vanish with their stars. Or maybe they're not as friendly as we are, and they've been avoiding us for a reason. Here's a nerdy one. Maybe they're out there, but we're just not listening the right way because it's not us being advanced enough. What if extraterrestrial civilizations communicate using something completely different from what we do? Like quantum entanglement or some exotic tech we haven't even dreamed of yet. Or maybe they exist in a form we can't even comprehend. Anyway, let's move from the silence of space to its most terrifying feature, black holes. You've probably heard the basics. Black holes are regions of space where gravity is so intense that not even light can escape. But here is an interesting theory. Black holes might be breaking one of the most sacred rules in all of physics. It's called the black hole information paradox, and this one made my brain hurt. In quantum physics, there's a rule. Information can't vanish. Not diary secrets, but the data describing every particle's position, spin, and motion. The whole essence, so to speak. Even if you destroy something, like burning a book to ash, the atoms and energy are still around. And in theory, big emphasis on theory, if you had super advanced tools, you could still figure out what was written in that book based on the particles and energy left behind. But when something falls into a black hole, a star, a spaceship, a giant pizza, whatever, It disappears behind the event horizon, and then, over time, the black hole itself slowly evaporates by releasing tiny bits of energy called Hawking radiation. Here's the problem. Hawking radiation dribbles out like random static, carrying no obvious hint of what the black hole swallowed. And if the black hole disappears completely and that information never comes out, it's like the universe just deleted the file with no backup. That breaks the no information loss rule. Some scientists think the information might be hidden in the radiation, but scrambled in a way we don't understand yet. Others think it gets imprinted on the surface of the black hole. And some say maybe we've got something fundamentally wrong about how the universe works. Before we figure out that one, let's pull back from black holes and take a wider look at the universe itself. Because even the way it's expanding doesn't seem to add up. This one is called Hubble tension, and it's not about drama between scientists. It's about a simple question. How fast is the universe expanding? Now, this should be easy to measure, right? For people good at math, I mean. Turns out, scientists have two ways. One looks at the early universe using the glow left over from the Big Bang. The other checks how fast galaxies are moving today by watching exploding stars. Except here is something funny. Those two numbers don't match. You'd think maybe it's just a measuring glitch, like, oops, forgot to carry the 1, but nope. It's more like checking the speed limit sign and then pointing two radar guns at the same car, and both showing vastly different results. This cosmic disagreement might mean that dark energy, the thing driving the expansion of the universe, is changing over time. Or that there's some secret ingredient baked into the early universe we haven't discovered yet. Either way, the universe seems to be expanding in a way that breaks our models. So it's possible we're missing something big. Or that reality is playing by guidelines we haven't written down yet. Alright, we've talked about how black holes might erase information. However, there's something just as weird. What if things in the universe don't decide what they are until you look at them? That's basically the idea behind the observer effect. Imagine you're tossing tiny balls at a wall with two holes in it. You'd expect each ball to go through one hole or the other, right? But if those balls are actually particles, like photons or electrons, something weird happens. If no one's watching, they act more like waves, and they go through both holes at the same time. But the moment you try to watch them, they stop doing that. They choose one hole and act like regular balls again. It's as if reality holds its breath until we look, then locks in what it is. But were they? Or did our act of looking force the decision? Nobody's really sure. However, that's not all. We didn't even have time to get into the time symmetry paradox, where the math says time should flow both ways. But in real life, it only marches forward. Or the cosmic horizon paradox, which asks how far apart regions of the universe, too far to ever communicate, somehow ended up looking exactly the same. Or the simulation hypothesis, which, yeah, let's just say that one deserves its own video. These paradoxes aren't just cool thought experiments. They're clues, little cracks in the surface of reality. And that's what makes it so exciting. See you next time.
That's it for today. So hey, if you pacified your curiosity,